Are you looking for a free CAD software for your DIY projects? Well, don't look any further. FreeCAD has got you covered. As the name suggests, FreeCAD is totally free of cost and an open source software. You will not have to sign up anywhere to download the software, and there is no subscription fee at all. Just like the old days, you install the software and you do whatever you want to do whenever you want to do. So let's get on freecad.org/downloads and download your version of FreeCAD 1.0 for your computer. Welcome back. I want to start today where we left off last week. So we are opening up the old file, dragging and dropping it in the FreeCAD work area, and that will open it up. As you can see, we have two bodies that we built with two sketches in there. This one I forgot to rename, so let me go ahead and rename that as sketch. It was X plane. Now today I will be giving some 3D shape to this model, and as you can see, these two sketches will help us do that. So in part design, we will have to have an active body to work in that body. None of these bodies are active. If you right click on the body, you'll see that this is unchecked. So I can check it to make it active, or just double click on it. That will also toggle active and inactive. So I want to build this base model by having a common between these two models from these two sketches. So I want to extrude them. I want to give some 3D shape to these two-dimensional sketches. So I want to get into first model, activate it, select this sketch, and come over in the toolbar and pad it. Now you'll see the preview says it's padding up to 10 millimeter, and then on the type it says dimension. There are multiple other options in there. Dimension is the most used one. Each of these has their own uses. So where is one dimension, and there also it has two dimensions. Let's try two dimension, right? And it's giving me 10 up, 10 down. So if we were drawing from this face, this length is going upward, the second length is going downward. I want to keep it like that. I want to take it downward 5 millimeter, and then length upward, let's go crazy, say 50 millimeter for now, right? We will come back to this, or maybe 70 even, right? We'll come back to this to update these values if needed, but we want to make it such values so that this vertical height contains the second sketch that we will be extruding upon. So that's why we can go above and beyond to this limit. And two dimension gives us both upward and downward extrusion of this sketch. And that's straightforward. And then if you wanted to taper something, say if you wanted to have like a 10-degree draft on the sides, it can do that, but we don't need that right now. So we'll just make it 0 and then make it okay. So that was pretty simple. Select this sketch. So we'll do it one more time here, right here on the second body. So we will select this sketch, pad it, and then dimension wise we will say 2 dimension. And again on this one, let's adjust it. We want to take it such a way that it will cover the previously created body in its entirety. So we will go with, say, make it 80 on the top side, maybe bottom side, and let's say 80 on the top side. So because we are going to make an intersection, as long as they are covering each other, it doesn't matter if you're going more than what you need, you are fine. All right, so we got two of our bodies, but this is half, right? And I'm gonna go ahead and mirror it over so we can have like a full body. So then when I mirror it over, I will explain it just a little bit more, but notice how these two bodies are differently selectable. So this is like if I hit space on the body, you can see that it's gone. So this is a totally separate body. So we have two different separate bodies selected differently, can be selected differently, and can be done whatever we want differently, separately. And with that, let's go back to the second body, double click on it to activate it. Select the pad. I want to mirror it over on this side, on the right side. So select that pad and then come over here. This button, it says mirrored on the toolbar. You can also find those from this part design. It's easy. It's on the toolbar. So we select mirrored, and now it is asking us which plane we want to mirror it against. By default, it shows a plane for us, YZ plane. So it says on the plane, it says horizontal plane, vertical axis plane, or like we can go with base. So on this one, because the model is built on the base, the YZ plane and the vertical axis plane are the same. So we can go either of those. But these two are different things, and then sometimes they come in handy. So we can select either of the vertical axes or base YZ plane. And then you can see the preview. We are getting this full thing to the full width. Hit OK. All right. So we got our full body from XZ and full body from YZ. Now we want to have a common area between these to have our base block. So double click on the active body to inactivate it. And then open up a new body. So this is going to be, I'm going to say base block. That's where we will be building our dressing. We'll be applying our dressing features. So create a new body, and then we want to do a Boolean operation right here. So Boolean operation is plus, minus, those sort of kind of thing. That's called Boolean operation. And so it has plus, minus, and intersection. So we can cut things away, which is, we can do it without the Boolean operation. We can do the pocketing thing. We can add things in there, fuse, and then we can have common. So common is the one that we will be doing. So we selected common, right? And then add body. So I want to add this one first, and then hit again add body. Now it's showing the available bodies for us to select. We want to select the second body. Now it is giving us this feature that will be as the common of these two bodies that we have selected. So that is the preview. If it looks all right, if you like what you see, hit OK. So we have our base body done. It just looks like the one that we had in our technical drawing. That's the one. So it has most of the features, but it doesn't have something. It doesn't have this dressing in there. We'll have to work on that. So bulk of the work is done. Now we can work on our tiny little dress up features. So let's take a look at what do we have in there. So we have, there is a slot, a groove on both sides, and there are two holes that's going from this side, which is perpendicular to this face, and then there are a counter bore on this. I believe there is a counter bore from the bottom side as well. So those are the four features that we will be now working on. If you will notice that now we have only one body. The previous two bodies has been booleaned into this body. So we will be working on this base block now. First, I want to take a look at this technical drawing, and here you can see that there is a screw hole that goes in there. So let's work on that. So we will have to draw a sketch. You see this face is not like in parallel with the horizontal axis. So we will have to draw a sketch that goes perpendicular to this face right here, as you can see. So maybe I want to take this drawing on XY plane, if that helps. There. So we'll have to draw this, and what I will do is I will draw it on this side and then mirror it over on the other side. So we'll be only working on one side. Select this surface. That already looks like curved on this side, but it's a straight line if you look at from the top. So that's a plane. So select that plane and then hit sketch. So what they will do is that will create a sketch on that surface, right? Just draw anything. you'll see if you come out of the close, so you see that that sketch is sticking to that plane, to that surface. And that's the way to do it. There are multiple other ways to do it. There is a long-standing issue, topological naming problem in FreeCAD that shows up every now and then. So to mitigate that, there are multiple other best management practices, BMPs. So we will talk about that in later video. There is already a video that I made talking about this, but with this new version, it's a lot mitigated. So keeping that in our mind, we are just attaching our sketch directly to this face. Select that face, draw the sketch, and then draw a circle there. This is going to be the inner one, so I'm going to go ahead and apply an 8mm diameter to it. And then on the technical drawing, it says it is 33mm on the right side from the center of this, and getting external geometry. So this is the first time we are using this button. What it does is, from this model, existing model, it will draw a line in our sketch. So that's called external geometry. That will help us decide where the center of this circle that we are trying to find. So it giving me the whole diameter of it, so the center is exactly right in the middle, right? So what I'm going to do, I'm going to create a point right in the middle. So if you bring it in the middle, it's showing you that it's picking a choice in the midpoint. You can look from the symmetric icon in there. So we stick it there, right? And maybe I want to make it a construction geometry, that point, so it doesn't show up later on, but I need that. So take that point and take this center, correct the view, and then hit D on the keyboard. So that distance is going to be 33. Okay, so that's one way to get a reference from an existing structure or an existing sketch. Just use this external geometry GX from the keyboard. And that solved the horizontal distance. How about the vertical? It's in the middle. We can zoom that. So I think the height was 32. If you don't remember it, you can take this line as an external geometry and then make another point in there. And this time I intentionally placed it somewhere else. So what I want to do is I want to find that manually. So take this point, not this center, the point on the line that we just drew, and then take the lower point and take the middle point that we just want to place it in the middle. So sequentially, two ends first and the middle one, and hit S on the keyboard. That places in there. So that's also how you apply symmetry by default. The first one we just chose to get the suggestion one, and the second one we found it ourselves. All right, and now, so this is going to be on the same horizontal plane. So select these 2 points and hit H on the keyboard, or this button up here, constrain horizontal vertical. That places it in the middle. So that is our sketch. It's pretty simple, right? We want to make a hole through it, and we just need a circle to know like where the hole will go through, and then we will now configure. So come out of it and rename that as sketch side pocket, something that you can recognize this name later on. So found that. Now let's hide this for a minute. You can see that that point is showing up. That's the point that we just drew because we wanted to have this midpoint. We don't want that point to show up. We want only this circle to have it. Anything else other than that, this has to be a reference or like construction geometry. So select that point and hit GN on the keyboard, or just make it construction geometry from there. And now you can see that that point is gone, and that's the way it should be. All right, let's bring our object back. And so this is the thing. You have the sketch. Anything that you want to cut out from the middle, from the side, either way, you make a sketch and then select this sketch and hit this button, pocket. The next to pocket is hole. A hole on the side. A hole is like a pocket with advanced features in it. So because we have two different kind of things in there going on, It is called counter bore hole. So we are going to use the hole to create that pocket. Now it has multiple options for us to go through. So the length of this hole is, all right, so we'll have to do some calculation. This hole is going to be from this center to 22 millimeter inside there, and that center is at 35 millimeter from this side. So 35 plus 22, so that is going to be the length. So in the dimension depth here it says 25 millimeter, actually it is going to be 35 plus 22, right? We can do arithmetic expression in here. And then it's not tapered, right? And we come all the way down to here. It says hole cut type none, select counter bore. On here we'll have to select a diameter of 8 millimeter. That's the through diameter that goes in there, and the outside diameter is counter bore diameter is 14, so we select 14 in here. And depth, counter bore depth was given as 10 millimeter, so there. So counter bore, what does it makes an allocation for the screw head in the beginning, so it's a bigger hole, and then it goes through the through hole. And then the drill point, it says flat, as if it was like a flat hole in there, but we have a pointy thing, so that is the angled. It's a typical 180 degrees, let's not worry about that. But if you can see, the hole goes through here and then it goes all the way somewhere here, so 22 millimeter from the center inward. Now so that's how we make a specialized hole, counter bore, counter sink holes, threaded screws, something like that goes in there. So if you right click on the object, the final object, and toggle transparency, you can see that there is our hole we just created right in there. Now at this moment, let's think about it. So previously, when we created two sketches and then two bodies, those bodies were selectable like separately. We could select two bodies separately and then made that this intersection in a Boolean operation. But the Boolean here, and then on top of that we built another feature in the hole here. We didn't have to do any kind of Boolean. It just integrated, it cut it out by default. And that's the beauty of part design. If you are working within the same body, anything that you work, it is built upon on the previous feature. So if you added something up here, for example, you select this sketch, draw another sketch on here, for example, for a circular tower, right? And then extrude that for 20 millimeter. So it is by default, because it's within the same body, it is added to the previous one because it was an additive feature, right? If you made a hole instead, it would cut through. So let's delete that pad, select that feature, that sketch, and then make a hole instead, right? Make a pocket for 5 millimeter. So it cuts things away by default. So that's the basic difference between part and part design. If you're working in part design, you don't have to manually delete that part that we just created. Based on if you are editing additive features or like subtractive features, it will do the subtraction or addition by default. So we'll have to keep that in our mind depending on what we want to do. Sometimes we intentionally want to do it, sometimes we try to avoid it. Like the first phase, we did not want them to merge together because we wanted to do an intersection. So if you are planning for an intersection, keep those bodies separate. Other than that, you can keep working on the same body because it will be less work for you to add or to subtract. Those are things done by default. So remember that same body, by default subtraction and addition. Different body, you'll have to be really intentional to do that. All right, so now we have this hole integrated in the body. Now we want to mirror it over on the other side. So what I want to do is I want to select that feature that we want to mirror it over on the other side. So we don't want to mirror the Boolean. The Boolean is the main body, it's there. We want to mirror the hole only. So select the hole, this one, and then mirror button is right here as we used earlier. And here we again want to select this plane, YZ plane. So select the YZ plane and then see if it is popping up right here. It is. So hit OK. Mirroring is pretty simple. You select the plane and then that's it. It will just mirror it over on the other side. So that is our screw hole, counterbore specialized screw hole in there. Now we have to worry about counterboring this feature. Now looking at the cross section, so this is the cross section that goes through this main body. Looking at this, looks like this counterboring is done on both sides with different diameters. When I started building this model, I thought of if I wanted to make it a hole, just like what we did, so we could have this counterboring there. But because we have two counterborings in there, I wanted to make it separately. So what I plan to do is I plan to make a revolute, a group card, to have these both cards done at the same time. So I'll have to draw this sketch in the middle. Luckily, we have the origin right at the center of this circle, so it would be easy for us. So let's do that. I want to draw this sketch, half of it, so I can revolve cut on both surfaces at the same time. So I want to draw a sketch on this face, which is XZ plane. So let's take this drawing on the XZ plane, so that way it helps us, this drawing. And then let's draw a sketch on XZ there. So by default, you can see that it's showing us the cross section of that goes through the section. If you didn't want that, you can click this button, view section, and that will show us the whole thing. But we want this section right here. And now what I want to do is I want to take reference of these top and bottom surfaces, so we don't have to do all the measurements. Now I'm going to go ahead and hide this, and then take reference, so GX. I want to take reference of this edge and this edge. So this gives me two reference points to start working on, right? And now if I wanted to, I can hide this mirror and start working in here. So we want to draw half of it. So let's take this half and come over here. I'm using polyline. Now because there's already one hole in there, we'll have to be careful about those diameters. We'll have to be careful about those diameters anyway. So let's fix things up. Let's make it horizontal. This one horizontal too. And all of them are straightened up. So we have the lower side. The diameter is 50 millimeter. So that's 25 millimeter radius. On the upper side, this diameter is 43. Radius would be half of that. And this internal diameter we had was 10. So this is going to be at, say, 5 millimeter. Okay. Now, if you'll notice, we have in the background, we already have that cross section in there. But notice that the cross section goes through, not exactly through the whole center of the hole. The cross section goes through right here. And that's why the underlying cross section, these holes are not represented in there. So don't take that as a reference. And now the height wise, we can take the lower side as a reference. This on the underneath the drawing, I think this is 5 millimeter and this one is 10 millimeter. So that is our revolve sketch, right? It's a fully constrained. So bringing back our mirror, that's where that sketch is. Now you can see that this line is far inside than what we had in the original drawing. And although it's a mistake on my end, I would not worry too much about it because we are cutting things away. If it was like inside the body, would be a problem. But since it is like outside this cutting zone, it's okay. So we have that sketch. Let's rename that as, say, sketch center groove. Groove is called what, if you see here, it is additive pipe, that's subtractive pipe, and here is revolution, and that's what in the subtraction side, so it would be subtractive revolution is what is called groove. So we take that and then groove it, right? You can see that it's showing us a default cutting area, something like this, and it is showing the axis is vertical axis, and which works for us. So hit OK, right? And now if you look at that, you will see that it did not cut the whole thing down because we had it fixed right this level, and this side is not at that same elevation. So we can go back to the groove. Let's see if I can make this one 15. Oh, that taking it the reverse direction. So what I'll do is I'll take this length as my dimension 17. So make it reference, right? We're trying to do some calculation in here. So if it is 5, this is going to be 17, right? And now it is only reference. It is a reference, so it's not driving. It's just for there for us to give us information. I want to make that driving and then make this one like a reference distance. So select these two. So select this one, control click the other dimension, and then toggle. So this is the toggle driving and reference constraint. So we click on that. That makes this one, the which was to be a reference, becomes the driving distance, and this is now reference dimension. Now I want to increase that 10 to say 15 so that the line comes up somewhere here. And I think this line is restrictive right here. So I'm going to go ahead and delete this line for now and make this driving geometry and make that 15. Right? And that brings it down here. And I can make it a closed square there. So we have a fully constrained sketch that covers the entire section. And hit OK. So that should be reflected right away. All right, what else do we have? We have another hidden feature in here. All right, let's hide that. So as you can see, this line, the cross section is going through the center of these tiny little holes on both sides. And we can see that those are counter bore holes at the bottom. Right? So we already had those built in there. And now we can go counter bore them. Now, I wish I did not build in those in here to begin with. I'll be honest. But since we already built it in there, we can apply a second feature to make it a counter bore hole. So what I will do, all right, let's bring our group back. Make this on XY plane. Okay, this is what I'm going to do. I'm going to go ahead and build a feature on XY plane from the bottom side. So draw a sketch on XY plane, right? And in here, now I want to take reference of those two holes. So bring our cross section back, take the external geometry and select on one of these edges. So this one actually is giving me a solid center. This one is giving me a B-spline. And since I have options to choose from, I'll take the solid center one. So I don't want the B-spline. Let's take that, delete that, and this one should do. All right, let's do the cross section. So there is the center. We want to draw one circle just like that. So this is going to be a 22 diameter hole, and then I want to mirror it over on the other side. We can do it later on. Let's take a look. We have that sketch sitting lying down here, but it's on the same center. So now I can take that and make a pocket. You can see that nothing showed up. So let's see if we can make the 10. Does that show up anything? No, because it is pocketing on the other direction. So we select reversed. Now we can see that it's cutting something, right? So we want to cut it up to, say, so it cuts around somewhere here. So we want to make it a plane surface. So let's make it 15. Oops, not enough. So let's go back and we'll just increment it, say maybe 28. That's what the, yep, there it is. 28 does it. And that's how you make a counter borehole without going into the whole feature. So there are like 2 pockets in there. And then we want to mirror it over on the other side. So select that pocket and mirror it. We take the vertical axis and then mirror it over. All right. The last but not the least is had to have some groove on this side, on both sides. So now we'll have to be very selective about where we draw the sketch and where it goes, because previously on this one we just draw it at the bottom and then hit up unless we went to our desired location. This one we will have to be careful about where we want to draw it. So if you look carefully on the technical drawing, all right, so that's the drawing underneath. I don't see it, so I'm going to go ahead and move it over somewhere there. All right, so this sketch, the hole that we're going to make the groove on the side is at the middle of this height. So we'll have to be careful about where we place it. Maybe we can place it right here and then pocket it upward. So this, if it is 17 in total height, the groove height, and then the total height is 32, so that's 15 millimeter difference. Split it in 2, so this sketch will be sitting at 7.5 millimeter from bottom. So let's do that. Let's make, I'm gonna go ahead and position this image so it doesn't look bad there. So let's make a sketch on XY plane, right? And just draw something, just anything. Say this is what I wanted to draw. Bring it over somewhere here. So this sketch is sitting at the bottom. We want to bring it up at 7.5 millimeter above. That's where it is sitting. So what we want to do is, I'm going to go ahead and rename that first, sketch side group, right? And then, so select this sketch in the data pane, go to under attachment offset, and in the position on Z axis, here it says, we say 7.5. So doing that, it moves upward. It was at 0 level, now it is at upward level. So having that is rectangular, just anything in there, actually gives us a reference to see actually what happened here. So it is moving upward. So now we can go back into the sketch, take our random drawing, delete it. Now do what we wanted to do, right? We wanted to have a groove that goes around here. So we need that center of that, the big hole that we want. So we can go back to our first sketch and then actually find it, or we can just reference it. So take the referencing button, and we don't see the model. So turn on our cross section view and take external geometry references. Select this button that gives us the center. Let's may as well do it this one here too. And take the external geometry reference off. Turn on the cross section view. Now we have 2 reference centers. So you can see down the dashed line, that's where we want it to be. So take an arc around the center. So that's a 32 millimeter radius. So I'm going to go ahead and apply the 32 right here, and then come it over on the lower side. Now we can make all these 3 sitting at the vertical plane. So that's a fully constrained sketch. Now that much we have to cut it out. So what I'm going to do, I'm going to draw another sketch somewhere outside, say 40 millimeter. Again, because it's a subtraction, as long as you are covering the main thing, don't have to worry about if you're doing on the outside too much. So let's make it like that. I definitely want to make it vertical because that cut is important. And there, that's our cutting surface right there. We have that sketch sitting up here, and what I want to do, select that sketch and pocket it. Now if you noticed, this pocket is going downward. That's what happened on this one, so we had to select reverse, so take reversed, and now it's going upward, and we want to take it upward by 17 millimeter. So let's make it 17 millimeter. There, so that's our first groove. So this is side groove, right? We want to mirror it over. So actually, now that I'm thinking, maybe when I was working on this hole, we worked on the hole, and then we worked on this counter boring, and then we worked on the side group, and then we could mirror all of them over in the same. So that's also another thing. That's where the thinking ahead works. So if you wanted to mirror them, all of them all together, you could do that too. All right. So we'll just take this one and then mirror it over on the other side. Take the recommended vertical sketch axis, and then it shows up right here. Hit OK. If it doesn't show up, try one of these buttons. I will explain them later in the video, but for now, if one doesn't work, try if another one works, right? All right, that's all the features that we needed, except some chamfering and filleting. So filleting is rounding the edges. Chamfering is chamfering, like, make it a plane at an angle. So filleting, let's do that. Select this edge. When it comes to filleting, this is the fillet button, and there's the chamfering button, two most used dress-up features. When it comes to chamfering and filleting, if you select part of the edge that's continuous, it's equivalent to selecting the whole thing. So we just selected it, right? And then select fillet. You can see that the edge is showing up, and then it's showing a preview that it's going around. I think we have 2 millimeter fillet, so hit 2, and that shows up in there. Now if you wanted to add more things in there while you are at it, let's do that. Select the lower side and then preview it. It's doing the same thing, 2 millimeter around. And I believe we could select this edge, and this edge. Also from the lower side, take part of that, maybe not here. All right. And those are all 2 millimeter fillets going around, and hit preview, see if that worked. Now fillet, you'll have to make sure, like, it's you're doing it right, because fillet is kind of sensitive in for design. Okay, we got all of them around. Oh, we missed one, so select another one there and preview. If it looks all right to you, if you like what you see, hit OK. So that's our first dress up. And then I think this edge is chamfered, right? So let's do that. Select that edge and then chamfer it for 2 millimeter. We are using equal distance chamfering in the middle, but if you wanted to go like wild, you have two distances. You have distance and angle. So there are two other modes available in chamfering. In filleting, it's simple. All right, my friends, that's our object. I think that's it. We just built our first object in FreeCAD in 2 videos. It took a minute to finish it up, but I'm happy we did it. I hope you liked this one. In the next video, I'll show you how to develop these technical drawings. So once you draw something, if you wanted to express that thought to someone else in the technical way, you can use this technical drawing to do that. So I'll show that to you in the next video. And also in the next video, I'll show you some alternative methods. Talk about some alternative methods, how you can approach this same problem in different ways. Know that there are always multiple ways to approach a problem, and if it works for you, that's the best way for you, right? And I hope you like this method, and I hope to talk to you more on this in the next video. Stay tuned. Thank you for watching. See you later.